Hi class, this is Professor Smith. I'm going to be doing a movie on binomial problems basic. In this example, we have the workers' union at a particular university is quite strong. About 94% of the workers employed by the university below belong to the workers' union. Recently, the workers went on strike and now a local TV station plans to interview 5 workers, chosenly at random at the university to get their opinion on the strike. What is the probability that exactly 3 of the workers interviewed are union members? Round your answer to at least 3 decimal places. If necessary, consult list of formulas. So in order to do this problem, we are going to use the list of formulas. So I'm going to pause here and make sure that you can see what I can see on the screen. So now I've selected binomial random variable, and we see here if x is a binomial random variable with parameters n, p, and x, and any integer from 0 to n, then the probability that x takes on a particular random variable x is given by this formula. I'm going to open up math type to discuss this formula more in detail and to discuss those parameters n, p, and x. So now I've opened up math type, and we have our formula again, the probability that the random variable x takes on a particular value x is given by n choose x times the probability p that raised to the x power times 1 minus p to the n minus x. So let's discuss what are these variables n, p, and x. N represents the number of trials. X represents success, and P represents the probability of having that success. So let's take a look at the formula using values for our letters. So let's take a look at n equal to 10, and you can think of n as the number of times you toss a coin, the number of times you spin the wheel on the spinner applet, the number of people in the sample size. So n would be 10. Then I have here, let's take a look at what does it mean, or how would we find the probability that the random variable x is equal to 4. Then the formula becomes 10 choose 4 times p to the 4th power, where p is the probability of success, and the success could be tossing a coin, the success could be getting a blue when you spin the wheel, the success could be that you're a union worker. Raised to the 4th power, because we want to know if there's 4 tosses that are heads, that's why it's raised to the 4th power. And you have 2 choices with the binomial experiment, a success, which is p, and then the complement, which is a failure, 1 minus p. And that's all raised to the 10 minus 4 power. You say, well, why is that so? Well, there's 10 trials, 10 tosses of the coin, so 4 of them are going to be successful, then 6 will, or heads, then 6 will be tails, or vice versa. So we notice here that we'll have 10 choose 4, so that 10, which is our number of trials, the bigger number is always first. 4 is the number of successes. Notice that that's also the exponent on the probability of success, which is p. And then 1 minus p raised to the 6th power. So notice that the 4 and 6 add up to 10. So let's take a look at this same example now using different values. So let's take a look at x equal to 3. Then when we take a look with x equal to 3, we have 10 again, because that's the number of trials, 10 choose 3. P is now raised to the 3rd power because we want 3 successes. And then the complement, 1 minus P, is raised to the 7th power. And what's 3 plus 7 on a good day? It's 10. So these 2 numbers will always sum to 10. So in this last case, we had 4 and 6, they sum to 10. Now we'll have 3 and 7 will sum to 10. The choosing of 3 and then 3 to the power, those will always match up. So let's take a look at one more example when we have x equal to 8. Then when x is equal to 8, then what we have is 10 choose 8. And notice that choosing 8 is going to line up. Oop, my arrow color is white, so you can't see it. So we'll notice that the 8 power here is going to line up with that 8. And then we'll also notice that if you take 8 plus 2, that's going to give us 10. So now let's go out and do our example that we had. In order to apply the binomial theorem, we need to find the values for n, p, and x. In this example, we're interviewing 5 workers. So if we're interviewing those 5 workers, that would be considered our sample size. So that's going to represent our n. So n is going to equal 5. Exactly 3 of them need to be union workers. So if 3 of them are union workers, that's going to represent our X. You can think of that as our success. And then the probability of success is equal to, well, what's the probability that they're going to be a union worker? And we know that they're going to be a union worker, it says here, about 94%. So the probability of being a union worker is going to be 0.94 when we convert percent to a decimal. So P is equal to 0.94. Our formula from math type said that it was equal to N choose X times P to the X power, and then 1 minus P to the N minus X power. Replacing the values, then it's going to be 5 choose 3. So from the 5 workers, we want 3 of them to be union workers, times the probability of 0.94 to the 3rd power. I apologize for my mouse writing, is really kind of sad. There we go. And then 1 minus 0.94, we can either do that with our calculator, or we can think of it as money. 1 minus 94 cents is 6 cents. And then 5 minus 3 is 2. This is n minus x, looks like an n minus 7. So it's going to be 5 choose 3. And then 5 choose 3 is equal to 10. Again, 5 choose 3 is 10, and I'll come back and show you where that 10 comes from. 0.94 to the 3rd power, 0.06 to the 2nd power. So let's use our Alex calculator to evaluate that probability. I'll hit the X to the Y key to raise it to the 3rd power. And again, instead of doing the 0.06 like I did in my head, you could do 1 minus 0.94 and then raise that to the 2nd power, or you can write it as 0.06, either way. And when you do that, you get 0.02999, and then they say round your answer to 3 decimal places. So then we know that the 4th decimal place is what's going to call the shots. So 1, 2, 3, 4. So this value here, that second 9, is, since that's larger than 5, then that means we're going to increase the previous digit by 1. So if you add 1 to that 9, that's going to round that up. You can think of that 0.029, and you're adding that 0.001. That's going to round it up to 0.030. And so we have that rounded to 3 decimal places. So let's talk about 5 choose 3. So it turns out we can use our factorial formula for 5 choose 3. So 5 choose 3 is equal to the following. It's equal to 5 factorial divided by 2 factorial, pardon me, 3 factorial divided by 2 factorial. Notice that the two numbers in the denominator add up to 5, just like the exponents do. So we have a 3 and a 2, which add up to 5, and we had a 3 and a 2 that add up to 5. So it turns out when we simplify the numerator by rewriting it out, we have the following. It's equal to 5 times 4 times 3 times 2 times 1. But instead of writing 3 times 2 times 1, I'm going to write it as 3 factorial, because I have a 3 factorial in the denominator. So I have 3 factorial in the denominator, and 2 factorial is 2 times 1. So I can cancel those 2 factorials. So I can cancel the 3 factorial here and the 3 factorial here. 5 times 4 is 20, and 20 divided by 2 is 10. Or I can cancel the 2 into the 4. 2 goes into itself 1 time, and 2 goes into 4 2 times. And so then I also get 5 times 2, which is 10. So that's where the 10 came from in our computation. So let's review what we have here. The first thing we want to do when we're solving these binomial problems is the first step is to find our 3 parameters, n, p, and x. And I usually write them in alphabetical order. I have them here NXP, but NPX, like NPR, where N is the number of trials, the number of people in the sample, the number of tosses, the number of spins of the coin. The 3 is what they're usually asking you to find the probability of, that you have exactly 3 or exactly 5. And then the P is the probability of success if you were just pulling one person out of 100. What's the chance that you would get a union worker? And in this particular case, it would be a 94% chance that they would be a union worker. And then once we have those values, then we can substitute into our formula. So it's always going to be NPX, or in this case 5, choose 3, 0.94 to the power of success, and in this case 3, 0.06, which is 1 minus p, to the power of failure. And these two exponents will always add up to n. And then we just do the computation. And in order to compute the 5, choose 3, we can use the formula that it's equal to the first number, 5 factorial, over 3 factorial. And then to get the second number, 2, we just subtract. 5 minus 3 gives us the 2. What they're really saying is that there's 10 different ways that you can have exactly 3 people that are union workers out of 5. So let me just give you a visual of that. So I'm going to draw 5 boxes, and they're going to be little blue boxes. So 1, 2, 3, 4, 5. If 3 of them are union workers, then this is what it's going to look like. So I could have a union worker here, a union worker here, and a union worker here. That's one possibility. Another possibility is I could have a union worker in the first choice, a union worker in the second choice, and a union worker in the third. I could have a union worker in the first person that's interviewed, not the second, third, or fourth, but the 5th. So you can see right there, I already have 3 different cases. And it turns out that 10 is representing all the different cases. Here I have 3 union workers, so that's why I have that 0.94, 1, 2, 3 times. Again here, 0.94, 1, 2, 3 times. 0.94, 1, 2, 3 times. That's why the 0.94 is raised to the third power, which is our success. There's not just 3 that I have here, but there's actually 10 different ways that we can get 3 of them to be union workers. I've only shown 3 of them here. So the other cases, I could have a union worker in the second slot, the third slot, and the fourth. I could union worker in the second slot or the second choice, the third choice, and the fifth. So now I have 5 different examples, and I could write out the remaining 5, but that gets you an idea of where that 10 comes. So it's 10 different ways that can occur, so that's why we multiplied by 10. And in each case, you have 3 that were union workers and 2 that were not. So that's why we have 0.94 to the third power and 0.06 to the second power. So I hope this short movie, or maybe not so short movie, on the binomial basic was helpful. When I do the second example, I'm going to go out and show you really what makes a binomial random variable binomial. I said 2 choices, but it's more to it than that.